In Algebra 2, we'd have you solve that system by what? How would we solve that? Substitution? I do not think we would like substitution for that. 'Cause that would create... Elimination would be better choice. Substitution would create some ugly-looking fractions. Now, you could do it with substitution, but I probably would choose elimination. However, there is definitely a better way than that, which we'll talk about today. Now, if I had my way about it, I would teach you all of how to do these row operations. These row operations, like there's 3 of them. Interchange any 2 rows. Multiply all elements of a row by a non-zero real number. Well, you know how to do that because you've done elimination before. Add a multiple of one row to any other row. Well, you know how to do that too because that's what you do in elimination. Well, we're going to do that, but fast, because your calculator will be doing everything that you see up there very quickly. So, here's a system of equations. You were also taught how to do that by elimination, right? Add the first and the third equations together to get rid of z. Add the second and the third equations together to get rid of z. And then keep going with the whole process. And then you get it all the way down to like x. And then you start substituting back in until you get y and z. Well, we're not going to do it that way. We're going to do it much faster. We're going to create what's called an augmented matrix. An augmented matrix. What are the dimensions of that matrix? That is a 3x4. That is true. You can see that not only did we include all the coefficients, we also made a column for the constants. Right now, you need to go into your calculator. Like we did yesterday. So, your matrix button, it should be on the left side. Edit. Nice. Somebody remembers. Making a 3x4 matrix. And use those values right there. All right. Make sure to double check your data entry. If we miss a negative, we're going to come up with some nasty looking fractions. So, yeah. Either one because it's the same. So the augmented matrix that you're going to be basically typing is what you see at the bottom of the screen, but it comes from what you see up there. Okay? And double check your numbers just to make sure. Yes, sir. I do, but somebody just borrowed my charger, so. Yes. As soon as he is done borrowing it, I will get it over to you. Anybody not able to get things entered? Do I have any questions on getting things entered? Okay. So, Now, you don't need to write anything down here. I just want to show you something before we use our calculator to solve. We would have to, in my day, when we walked uphill through the snow, I had to do this by hand, okay? Which, if I had the time, I'd make you do by hand. What we do is we focus our attention and we want... do you see something happening right here? What do you see happening that we talked about yesterday? That I should say we talked about it a little bit. Do you see something that's starting to show up? Ones along the main diagonal, zeros everywhere else. What does that sound like? What if this thing turned into ones along the diagonal and zeros everywhere else? What is that we talked about yesterday in 7.2? Or you saw it in the video, whichever. Yes? Along the main diagonal, the ones, zeros everywhere else. It's called the identity matrix. Okay? The goal of this process is to get the identity matrix to show up right there in that box. And so all these row operations, multiplying and adding, you could see that they took the 1 and multiplied by -2, and they knocked this out, and they made it a 0. Well, then what would they do here? Right here, they would focus on that 1, and they would take that 1 and knock out that and knock out that. But you don't have to go through all those row operations because the calculator's going to do it for you. You're so lucky you didn't have the joy we had. I mean, literally, folks, when I had to solve these things, look at what we had to write out. We had to write out that we were going to take row 1 and multiply by -3 and add it to row 2 and replace row 2. And then we had to go through and write down every one of the row operations that we were going to use and do them correctly without a graphing calculator. No, you don't have to flip to that. Okay, we'll go back to the one we were working on. We're going to be looking for something like this in our calculator. Reduced row echelon form. Can you help me abbreviate that? RREF. REF. Reduced row echelon form. Now there is another calculator instruction that you have in your calculator called row echelon form. I'm really not sure the point. Because it's like stopping in the middle of what you're supposed to be doing. It doesn't help you with the final answer. This is the one I want. Reduced row echelon form. Okay. Quit and go back to the home screen. Quit and go back to the home screen. Go into the matrix section. This time going to the middle where it says math. As I showed you in the video yesterday, the first one, DET, stands for determinant. And you can use that to find the determinant of a 3x3 matrix. And there's lots of cool things in this list. As you go down, you'll eventually find what? REF. Reduced row echelon form. And if I want matrix A to be the one next that I type next, I go back to the matrix. This time I leave it on names. It's already highlighted by the 3x4, so I'm just going to type that. You see something that looks like an identity matrix? The extra one I have is the batteries. I don't know. It's all messed up, but I'll see if I can find to have some backups here. Did you get something that looked like it had the identity matrix in it? Great. What do you think x is? 1x equals what? 2. Nice. What do you think 1y equals? -1. Nice. What do you think 1z equals? You gave me the answers. And you didn't know about that. Ref. The calculator's doing all the row operations for you. So after we did the ref, we ended up with -2, 0, 1, 0, -1, 0, 0, 1, 3. So just as we described, right here is your identity matrix, and right here are your solutions. It's very, very nice. Just keep in mind, that represents your x, that represents your y, that represents your z. Alright, let's find some practice. Page 5. Looks like this. Solve it, folks. Use your machine and solve it. Yep. -2, -1, 3. That's you. X goes to 2. Y goes to -1. Z goes to 3. Check with your neighbors to see if you get the same result. Looks like a lot of you are getting negative 2, 7, and 3. That's correct. So solving the system, we know that x equals negative 2, y equals 7, z equals 3. Okay. Got one more example in here that I want you to do with me. Actually, probably. Well, try that one quickly. Okay, you do it together. What? Okay. 0140. That ain't the identity matrix. Okay. So see, we have a problem. Our z is gone. 0z equals 1. That's a problem. So when you see something like that occur, no solution. He would. We're good? Okay. Let's see what happens when we type this one in. Got the 1, 1, 1, 3, 2, 1, 4, 8, 1, 2, negative 1, 1. Throw some rough at it. See what happens. 0, 3, 3, 5. 2, -2. Whoa, got no z's. Got nothing. What I'm left with is like x plus 3z equals 5. Y minus 2z equals -2. That is not a complete, that's not a solved system. Which is why this is the idea of the question. There are infinitely many answers in this particular situation. The last one we had no solutions. This time, when you have a whole row of zeros, you've got infinitely many solutions. You won't be able to find a single answer. Could you do these kind of questions with ref? If so, what size dimension matrix would you create? Your augmented matrix would be what? It'd be a 2 by 3, wouldn't it? No, we're not going to do that. But you could do that for a 2 by 2 system. I do, however, want you to jump down to page 12, example 10. We did something similar to this last year in Algebra 2. And just for kicks and giggles, I'm probably going to put the y equals on the other side. We've been given 3 points. We've been asked to come up with the parabola that goes between those 3 points. What do you think we're going to do with the 3 points? Put them into the equation. Excellent decision. That's right, folks. We're going to be plugging them in. It's a great moment. If you even understand that. You don't get that kind of humor with subs. You really don't. Nothing. So if I'm going to plug in -1, 5, -1 is the x value, how many a's will I have? Come on, folks. Plug in -1 for x. How many a's? 1, right? -1 squared is 1. Right? How many b's? -1, right? Plus c equals 5, right? We plugged in the x value and the y value. You see that? All right, let's plug in 2 -1. How many a's? Come on, squared. 4 a's. Plus, how many b's? 2 b's. Plus 1c equals -1, right? That's my y value. 3, 13. How many a's? 9. How many b's? 3. We got 1c, and it equals what? 13. Solve it. Find the a, b, and c. Go. If I were you, I'd use ref. Good question. Alright, let's see what you got. Hopefully your augmented matrix looks something like this. 1, -1, 1, 5. 4, 2, 1, -1. And 9, 3, 1, course, you threw in a little ref, right? We ended up with what? 1, 0, 0, 4, 0, 1, 0, 0, 0, 1. And then you were able to write your equation, weren't you? Y equals something x squared plus something x plus something. You didn't leave that detail alone, did you? So what goes in front of my x squared? 4. In front of my x? -6. And lastly, -5. And no, you don't need the extra plus signs in there. You can get rid of those. See, that's a much nicer way of doing that as opposed to elimination. I think we had you do it with elimination. But we don't need to do that anymore. We got ref.